So here's one which is written quite short. Find the point on the curve given, which is y equals square root of x, that is closest to this point. So here we're minimizing a distance, right? If I draw this just to get some idea what's going on, here's the curve, y equals square root of x. Okay, so here's 3. And so you can see this, whatever, I'm not sure how well I drew this, but like somewhere here, there's going to be the shortest distance. I don't know if it's there, but somewhere here. This point you know is 3, 0, and this point you know it's x and square root of x because it's on the curve y equals root x. So what we want to do is minimize the distance between these 2 points, right? So use the distance formula, okay? Now I'm going to give you a hint or a trick, right? So the distance formula between 2 points, okay, is going to be the square root of the sum of the squares, right? Well, if you're going to take the derivative of this with that square root and everything, it's kind of gross. So if you want to make your life easier, you can, instead of taking this, you can minimize the distance squared, right? And the reason you can do that, now you can't do that with every function, okay? So the reason you can do that is because the square root, as we have here, is an always increasing function. So it's not going to change the maxima or the minima. So you can do that. You can also just use this. But it's a lot easier if I write it this way. X2 minus x1 squared plus y2 minus y1 squared. Okay? Much easier math, right? So where are my x2 and x1 and y1 and y2 and y1? They're over there, right? So I have 3 minus x squared plus 0 minus square root of x squared. Right, so this is actually quite easy now because all I have is square root of x squared, so that's just x. And I can even work this out, right? So 9 minus 6x plus x squared plus x. So this is 9 minus 5x plus x squared. Okay, so that is the distance. Now if I want to take the derivative to find the minimum, right, I have minus 5 plus 2x. So x equals 5 halves. Okay, so it is somewhere over here, though not quite. Maybe it's here. It must be this one. Okay, so I didn't draw it exactly right, but x equals 5 halves. We will double check, right? If this is 5 halves, d primed. Yes, if x is less than 5 halves, this is, wait, what am I doing here? Okay, so if I put in x equals 1, this is negative, and if I put in x equals 7, this is positive. All right, sorry, brain fart there. Whoop, it is a minimum. Okay, so your minimum happens at x equals 5 halves. And then y is, of course, the square root of 5 halves. So it's quite easy to do, and whenever you have a distance, you can use this trick. Whenever you want to, I mean, yes, when you have a distance, but when you're using the distance formula, you can use this trick to maximize the square instead.